executing birdwatch, but here bird is set to Mandarin duck. Let's call birdwatch. Now we get birdwatch, which runs console.log golden pheasant. It's finding the nearest bird, which is in this scope. Then we console.log bird outside the function. Bird is set to Mandarin duck. So this diagram kind of explains this scenario. Here we have two scopes. We have the orange or yellow box, which represents the scope of this function. Bird, where it's set to golden pheasant, is only accessible in birdwatch. But then we have this larger scope where bird, the first bird, was declared outside the function, so its pink box extends down below as well. And that's pretty much all I wanted to show you in this video. In this context, let and const will behave the same way. If I updated both lets to instead be const and run this, we get the same output. If I update them to both be var, we get the same output as well. But in the next video, we'll see a very significant difference between how let and const behave and how var behaves in certain scenarios. So we have more scope to talk about. That's next.
I'm gonna knock him out in the third though, probably. I wanna punch his ass though, son, first. Damn, motherfucker. Motherfucker. Damn it. Ain't do shit, nigga. Ain't do that kick. Ain't do goddamn thing, nigga. Shit. That punch ain't do a damn thing either, bitch. Motherfucker, nigga, please, nigga. Motherfucker, I do this, nigga. Motherfucker, I do this shit, nigga. Nigga. He's spamming fucking on uppercuts, huh? Man, that ain't doing nothing, nigga. He throwing fucking elbows like a bitch, huh? Punk ass nigga. Motherfucker, nigga, I do this, nigga. Motherfucker. Nigga, please. Man, he quit like a bitch. Of course you gonna quit, nigga. You can't damn fuck with me.
In the last video, we talked about function scope, where if we declare a variable with any keyword, whether it's let, const, or var, within a given function, it is scoped to that function. We don't have access to it outside that function. Now we're going to see a different type of scope, which is called block scope. And it doesn't necessarily have to do with functions, at least not directly. But I did mention at the beginning of the section, we would cover some function memories and content. And if you think back to one of the very first videos in the course, when I introduced let and const and also var, I said we would come back later on, that's right now, to discuss one of the main distinctions between let and const compared to var. So this is it, block scope. This is a very, very important concept around how variables work in JavaScript. So let's start with a simple example. Here's a conditional. If true, it's always going to run whatever code is in here. Let's declare a variable called animal and set it equal to eel. If I console.log animal outside this block, what do you expect?
God damn, he's big.
What will be printed out?
Oh, what's that boxer?
Nothing. We get an error. Animal is not defined. So what does this tell us? It tells us that animal is scoped inside this conditional. It is scoped to this block of code. Blocks in JavaScript are denoted by curly braces. Keep in mind this is very different than an object literal, which is also curly braces. This is an object. This up here is a block. So same thing if we had a while loop.
Yeah, that dude's boxer. God damn. You see, I forgot that damn kick. Damn, I forgot his damn moves. Shit, I forgot his moves. Let's see this shit, man. damn, motherfucker. God damn, nigga. Shit. God damn. God damn, nigga. You try to knock me out, ain't you? Damn, man. Oh my goodness, man. God damn. How tall is that motherfucker? God damn. Oh, I know what he's doing. Alright. Alright. That motherfucker. Oh, wow. Oh, I'm lagging bad. Yeah, that's why I can't unpunch. I'm trying to punch. It's not damn unpunching though, cause I'm lagging bad. God damn. Yeah, I'm lagging bad than a motherfucker. Like I can't even fucking punch for real. I'm pushing it. It's not damn unpunching. I'm gonna knock his ass out though. Oh, damn. Oh yeah. If I knew his damn moves, I would have been knocked you. Boy, oh my goodness. If I knew his damn moves, boy, it'd be over. I forgot his damn moves because I barely fucking play this shit. Hey, I forgot his damn moves. That's what it is. See, I forgot how to play this shit for real, Damn. What? God damn, I forgot his damn shit. Damn, I forgot his damn moves. Man, I'm lagging, man. Too bad, man. Damn. Motherfucker, you lucky I forgot his damn moves, nigga. Oh, you lucky as hell, nigga. Hold on, nigga, you hurt? Hold on. Hold on. It's over now, nigga. Hold on, nigga, you hurt? Hold on, nigga, that's all she wrote then, nigga. Hold up, nigga, you hurt? Hold on, nigga. Hold on, nigga, that's all she wrote. Hold on, nigga, that's all she, hold on, nigga. Motherfucker, that's all she wrote, motherfucker. That's all she wrote, nigga. Boy, I tell you, nigga, boy. He's hurt. I gotta stay on his ass, because he's hurt like a motherfucker. Oh yeah, I won that. Oh yeah, I'm winning then. I can play back some now. I'm winning. Yeah, nigga. Yeah, nigga. Yeah, nigga. Yeah, nigga. Yeah. I'm winning, nigga. I can play back. I'm winning. I got all the damn knockdowns. Shit. I'm winning, nigga. You gotta rush. I don't. Shit, nigga. You gotta rush, nigga. I don't, though, boy. Motherfucker. Nigga, I do this, nigga. Oh, man, I tell you, boy, you lucky. I forgot this dude's damn move set, man. You lucky. Oh, you lucky. I forgot all of this dude's moves. Because I haven't played this shit in, boy, so long. The fuck? Oh, it's good. I didn't fall. I didn't fall down. Oh, I'm good. I'm good. I'm good. Man, motherfucker. Nigga, I do this, nigga. Man, motherfucker. Nigga, I do this, nigga. Man, motherfucker. Nigga. Man, nigga, I keep on, lagging. Like, that's why I can't, knock him out. Because I keep on, lagging bad. Damn. The fuck? What? Damn, nigga. This game cheated me. How'd I fucking miss that, man? Man, motherfucker, nigga, I do this, nigga. Man, nigga. Motherfucker, nigga, I do this, nigga. Shit, nigga, I'm winning, nigga. Think you doing something. Shit, nigga, I'm winning this shit, nigga. Yeah. Yeah. Motherfucker, nigga. This game fucking cheated me right there. And, man, they cheated me bad. There's no way he hit me. What? This game is so fake. Dude, this game is so fake, man. Oh my goodness. Yeah, man, man, this damn heavyweight shit. Hold on, man. Man, nigga, please, nigga. What? They cheated me. They cheated me bad. They cheated me bad like a motherfucker. I forgot his damn move set too. Oh my goodness, I forgot his full damn. No, let me check out his damn move set. Oh my goodness, I forgot. They damn cheated me though too. Let me see. How do I fucking check that shit? Let me see. Well, is this it? I'm trying to think. Where do I fucking practice at? Man, how do I practice in this motherfucker? Man, come on, man. Oh, yeah, this is it. This is it. Practice mode. Okay. Where are these fucking moves at? How do I fucking check the fucking moves? Like, come on, gang. Man. Dude. Come on, man. Come on, man. Tell me it's a fucking move set. My goodness, this ain't damn showing me shit. This ain't showing me nothing. Oh my goodness, this ain't showing a damn man. This ain't showing a damn thing. My goodness, it ain't showing shit.
If we had a for loop or a for of, those are all blocks. The code we write between the curly braces. So this is not a function, but it appears that animal is still scoped to this block. And if I console.log animal here, of course it should work, and it does. We get eel, and then animal is not defined. So that's how let behaves. And if I did change this to const, and I rerun it, we get the exact same output. We have access to animal in the curly braces inside the conditional. We do not have access to it out here. Now if I duplicate this, and I change this to instead use var, you can probably tell where I'm going with this. If I run it, it works in both cases. Eel is printed here in the block and outside the block.
Fuck it.
So this tells us that
I'm gonna learn as I damn go then. Shit.
Than var.
Fuck it.
Back in the day, before let and const, we only had var, and var is scoped to functions, what we covered in the last video. There is no block scope for var. If we declare a variable using var in any block, like a conditional, a for loop, a while loop, it is not scoped to that block. We have access to it outside. And that could be problematic, and that is different than how a lot of programming languages behave, which is why let and const were proposed, among other reasons. So they also, there's a distinction between const and let. That was one of the reasons they were added in, to create const, but also for scoping reasons. So
I got that nigga quick.
Problematic. What's wrong with having a variable quick block and having access to it afterwards?
Damn.
There's a bunch of reasons, but let me illustrate a simple problem that used to come up occasionally. If we have a for loop using the var keyword, so for var I equals 0, I less than, let's make an array called, well, we'll just do animals. Let animals equal, and then we'll have grizzly bear, let's do panda bear, and spectacled bear. Spectacled bear. And then we'll loop over this using a for loop. I is less than animals.length, I plus plus, we'll console.log animals. And let's also console.log I. So we get 0, oh, well, I didn't mean to console.log animals.
Motherfucker. Nigga, spam motherfucker. Nigga, I do this, nigga.
We get 0, grizzly bear, 1, panda bear, 2, spectacled bear.
Motherfucker.
Here's the thing. Outside this loop, if I print I, it still exists, and it's actually set to 3, because of the way a for loop works.
Wow.
It's at 0, if that's less than animals.length, so we loop, and we add 1 to I. And then it becomes 1, and then 2, and the last index in here is 2. So when I is 2, we access the last element, and then it's incremented to 3. The loop does not run again, but I doesn't cease to exist. I is still here. We have access to it. And this could be problematic if you were relying on a variable called I, maybe one you had defined somewhere else, like var I equals 10. You might think that this I should remain as 10, but if we print I down here, the only I that we're getting is 3 from this loop. So even though I had a different variable declared with var up top, and it looks like, at least sort of upon first glance, that I exists only in this loop, doesn't use var, it does not. And that means that we have access to it afterwards, which can have all sorts of unintended consequences. It just makes it harder for you to know exactly where I stops. It's not going to
John Jones shit. I forgot his damn move. So I gotta pick damn somebody else.
Instead,
shit.
Down here, we do this with let. Let's see what happens now. So the loop still works great.
He fell for that fake.
I at the bottom, it's set to 10. And that's because this
he
fell
for that damn fake.
Is scoped to this block.
Fake to the body kick. He fell for that nigga.
The the only eye that exists is this one here.
Just the way he drew it up here tonight, saw that little crack of an opening, and
that nigga seriously fell for that shit.
If I declared up here, try to work it out, get an error, there is no eye. And the same holds true for const, though you wouldn't use const in a for loop because it's being incremented. That would break everything. As you can see here, it will yell at me, assignment to constant variable. The first time it tries to add 1, everything breaks. So I'll undo that change, we'll go back to let. The other thing that you can see right away, it tells you that these are not scoped the same way. They exist in different scopes. This eye here and this eye here is the fact that we don't get an error when we run this code. Normally, if we have 2 variables in the same scope with a given name, declared with let or const, let x equals 10, if I try and make another x and set it equal to t, we get an error. It says identifier x has already been declared. In this case, we're making a variable I with let, and then another I with let. On the very next line, they exist in different scopes, which is not block scoped. This I is the exact same I down here. So they are in the same scope. It starts as 10, and then we are redeclaring I as 0. And you can do that with var in the same scope. I can say var t equals 1, and then var t equals 5, which I cannot do with let and const. I cannot use the same identifier twice. So blocks also include things like while loops, conditionals as we saw. All of those rules apply for let and const. They are scoped to the block. So now let's just write a function that also includes a block within it called double array, which will double an array that is passed in. So if we pass in the array of 1, 2, 3, 4, or fine, 1, 3, 5, we should get back 2, and then 6, and then 10. Each element is doubled in a new array. We're not updating the original. So I'm going to write a function that is expecting ARR, some array, to be passed in. We'll assume it's an array, and then we'll loop over that array using a for let x of, or let's call it num of array. I'll make a variable in here called double, which is equal to num times 2. And then up here, I'll make a variable which will be an empty array. So I'll start with 1, I'll double it, which I do here. I have a variable called double. I will add that into a new empty array, which I'll call, what should we call it? I'll go with const, because we're not going to change the reference. We'll call this result. It starts as an empty array. And then result.push double. Okay, so what we have here is a function. We have const, which is scoped to the entire function, which is why at the end I'm able to return results, because result was defined in this function, not in a block. Then we have double, which is scoped to this block. We still have access to result. So within a block, we still have access to variables that were declared outside.
Ready?
We'll call double ARR on 1, 2, and 3. So 1, 2, 3, we get 2, 4, and 6. If I were to try and console.log double, run the same line, it does not work. If I instead use var or double, it does work, because var does not cease to exist after this block, meaning the last time through the loop, which was on 3, double is set to 3 times 2, which is 6. We have access to it down here, which is why we see 6. So this is just a quick example where we have different scopes going on. We have const result, which is scoped to the entire function. It's not inside of a block. We have, go back to let double, which is scoped to this block from a for of loop. So down at the bottom, we can still return results. We don't have access to double. If we wanted, for some reason, to have access to double at the end, we can define it right here. Let double.
Keeps on fucking changing my fucking stance.
And we still have access.
Like, come on, gang.
Double equals num times 2. If I run this code, we still get 2, 4, 6. I don't know why you would want access to double outside that block. We're only using it to push a value inside the loop, but we do have access. If you needed it, you can still access it, even with let, because I declared it in the function scope, and then I'm changing it within block scope. But I'm going to undo that, and go back to what we had earlier, where it only exists in the block. Okay, so to sum this all up, let, const, and var are three ways of declaring a variable. We've seen that. There's a big difference between let and const, because const cannot be reassigned, it's a constant variable, and both let and const cannot be redeclared. So we can't have what we've already seen, let x equals 1, let x equals 2. We cannot redeclare a new variable. We can change let at any point, but I cannot redeclare the same variable with the same name in the same scope. Var, you can do whatever you want with it. But the very important difference that we covered here is that on one side we have var, which is not block scoped. On the other side, we have let and const, which are block scoped. So if you declare a variable with let or const in a loop, in a conditional, in a for loop, in a while loop, those variables are scoped only to the confines of that block. If they're not in the block, if they're defined in a function, like we have here, we can access it within that function. It doesn't exist afterwards, which is what we saw in the last video, and the same is true for var. So var was the only option a couple years ago. Function scope, now let and const are here, block scope.
Oh, he might be out.
This nigga wanna keep doing that bullshit.
Lands a nice 1-2. Final seconds.
Punk ass nigga.
Somehow his opponent stayed upright.
I mean, he's still on his feet, but he's not up by much.
All right, let us now check out some of the action. All right, here we go now with our second 5 minutes. Yoel Romero versus Paulo Costa.
It's such a fast leg kick.
And he connects there with a punch, so pretty good striking display by him thus far.
Oh! An uppercut lands.
And both guys really throwing with authority. He's rocked.
That was a beautiful hook. It landed perfectly, and it hurt his opponent very bad.
Oh, he lands another strike to the body. He just continues to punish his opponent's midsection here in this round. So unofficially, 63 total strikes have found.
He didn't like that left hand.
He's got him hurt here. Man, hate to be hit with one of those knees to the body. Oh, straight right. Oh, big left.
Beautiful strike.
Romero's cheek looks like it's cut. Yes, it is. Starting to bleed a little bit now. Oh, no wasted motion. Oh, there, DC. He is hurt.
Massive hook land. And his opponent.
It doesn't return anything. All that it does
It
is
keep fucking changing my.
and then we have a function declaration. We're writing a function, declaring it, but we're never calling
Oh, this
it.
nigga's
So
a
if I
bitch.
execute inner from inside outer,
Damn,
let's try it again.
nigga, please. Nigga.
Now it is successfully console.logging Amadeus in all caps. Movie was not defined in this function, it was defined in its parent, the outer function, right here. Secondary to this, what if I tried to call inner from outside this function? I don't have access to it. It's just like I declared a variable inside of outer. I declared a function. It's called inner. I don't have access to it over here. I only have access to it inside of outer.
This game.
Unless
I hate
I were
this
to
fucking
return
game.
the function, which is something we'll see later on. So if I call inner from inside outer, this is getting confusing with the naming here. If I execute outer, it declares variable movie, says it's Amadeus. It knows about a function. We declare the function, we define it here, inner, and then we call it. So when it's called, it console.logs movie. It does not have a movie defined in here.
I forgot this dude's move set too.
From the scope of the parent function, which is called outer.
Man,
So
nigga.
lexical scope refers to the fact that nested functions are lexically bound. They're bound to the scope of their parent or of their outer functions. But it's a one-way relationship. It doesn't work the other way around. If I were to define a variable in here, let x equals 10, I do not have access to x outside that function. Just like regular function scope we've seen earlier on.
I'm not
If I run
damn
outer,
picking this dude again.
get
I'm not
Amadeus
fucking picking this
from the
dude
inner
again.
function running.
Hell,
The
fuck
variable
no. I
is
forgot this
successfully
dude's
declared
move.
in inner, but I don't have access to it out here. So a variable declared in one function is available to nested functions within it. And then finally, if I were to declare movie in this function, a different movie, say movie equals, what's another good movie? How about The Shining? What do you expect to happen here? When we call inner from inside outer, so when I execute outer, it will declare movie in the scope of this function called outer. Then we execute inner. Inner defines its own version of movie called shining. That's the value. And then we're going to print movie.toUppercase. Which movie is printed? The Shining. Behind the scenes, the thought process, if you want to think of it that way, inside of this function is when we reference movie, it's going to look to see, is there a movie in this function? Is there a movie defined in this scope? If it doesn't find it, it will look further up. Is there a movie defined up here? And if there is, then it will use that. So we could go one level further. As an example, we'll have movie Amadeus, movie The Shining, and then in here I'll do another inner function. I'll call this one extra inner. And we'll console.log movie.toUppercase.
I should have fucking called his ass.
So I'll make sure I call extra inner. So this is a very weird pattern, what I'm doing right now, but it illustrates
Come on, game.
play. So when I call outer, we define movie on this.
Are you kidding me?
Then we execute inner. In inner, we define movie right here with the value of The Shining. Then we execute extra inner. Extra inner does not have a movie defined inside, so it will look up to the nearest scope, which is the inner function, and use that value. So if I run outer, we get The Shining. If I were to comment this out, we don't get an error. It just continues up past inner, doesn't find movie, so it looks up again. Does it find movie there? And it does. And that's pretty much it. When you have a nested function, you have access to the variables declared in the scope of the parent function.
This game, man,
down
fuck
as
this
many
shit.
levels as you need to nest. It seems like it might be useless, not that useful, but as I mentioned, if you use things like React later on, you define functions that represent a component on your page. So you can, and in that to-do list component, you might have different variables like let to-dos equals an array, and let username equals something.
You ain't picking that dude
Then
again.
you would have different functions
Hell
for that to-do list. You might have one called add to-do. It's spelled to-do. You might have another one called remove to-do, and another one called update to-do, and they might use to-dos and username in their function bodies. So we're grouping it all together into a to-do list function, because that's what React wants, but we still break up our code, our functionality, into smaller pieces, and we have access to those variables declared in the outer function. Okay, so that's lexical scope.